Are you preparing for the CEH exam and looking for realistic practice questions with clear explanations? In this video, I have compiled 50 carefully selected certified ethical hacker questions designed to test your knowledge across key domains. But this is not just about questions collection. I break down every answer with detailed explanation so you understand the logic behind it, not just memorize it. Whether you are revising before the exam or strengthening your ethical hacking fundamentals, this session will sharpen your concepts and boost your confidence. Let's dive in and start mastering CEH together. Question number 51. Kate, a disgruntled ex-employee of an organization, decided to hinder the operations of the organization and gather sensitive information by injecting malware into the organization's network. Which of the following categories of insiders does Kate belong to? Option A, negligent insider. Option B, malicious insider. Option C, compromised insider. And option D, professional insider. And the correct option is option B, malicious insider. And the explanation is, so the malicious insider, called inside CEH Insider Threat Module, is an insider who intentionally harms the organization. For example, a disgruntled current or former employee who deliberately injects malware, steals data, or disrupts operations out of revenge or personal gain. Kate fits this category exactly as a disgruntled ex-employee acting with intent to hinder and steal information. Other options, including negligent insider, unintentionally causes harms through careless actions, for example, falling for phishing. Compromised insider is a legitimate employee whose credentials or account are taken over by an external attacker. And professional insider typically refers to paid spies or moles, for example, corporate espionage hired by competitors, not disgruntled ex-employees. Question number 52. In one of the following types of identity theft, the perpetrators obtains information from different victims to create a new identity by stealing a social security number and uses it with a combination of fake names, date of birth, address, and other details required for creating a new identity. Which is this type of identity theft? Option A, social identity theft. Option B, synthetic identity theft. Option C, child identity theft. And option D, medical identity theft. And the correct option is option B, synthetic identity theft. And the explanation is, so synthetic identity theft involves creating a completely fictitious identity by combining real stolen data, usually a legitimate social security number, often from a child or deceased person, with fabricated details like fake name, date of birth, address, and phone. The attacker builds credit history over time using this Frankenstein identity, then exploits it for fraud. For example, taking loans and credit card theft. This matches the exact description in CH Module 10 Hacking Web Applications or Identity Theft section. Other options, social identity theft impersonation on social media using stolen credentials. Child identity theft is using a real child's identity, often social security number, for fraud, not fake combination. And medical identity theft is stealing health insurance and medical records for fraudulent treatment or billing. Question number 53. Santa, an attacker, targeted an organization's web infrastructure and sent partial HTTP requests to the target web server. When the partial requests were received, the web server opened multiple connections and waited for the request to complete. However, these requests remained incomplete, causing the target server's maximum concurrent connection pool to be exhausted and additional connection attempts to be denied. Which of the following attack techniques was used by Santa? Option A, slow loris attack. Option B, ping of death attack. Option C, multi-vector attack. And option D, smurf attack. And the correct option is option A, slow loris attack. And the explanation is, so slow loris attack, code in CEH denial of service and distributed denial of service module, is a low bandwidth application layer attack. The attacker sends partial HTTP request header only and keeps connections open by slowly sending additional data or keeping the connections alive, never completing the request. This ties up the web server's connection pool, exhausting available slots and denying service to legitimate users, exactly matching the scenario. Ping of death sends oversized or malformed ICMP packets to crash systems and to exploit an old vulnerability. Multi-vector attack combines multiple attack types not specific to partial HTTP request, and smurf attack amplifies ICMP echo request via broadcast to flood a victim, which is reflection and amplification attack. Question number 54. Which of the following techniques scans the header of IP packets leaving a network and ensures that unauthorized or malicious traffic never leaves the internal network? Option A, ingress filtering. Option B, TCP intercept. Option C, rate limiting. And option D, egress filtering. And the correct option is option D, egress filtering. And the explanation is, so egress filtering, code in CEH firewalls and honeypot's network security module, examines outgoing or leaving IP packet headers at the network perimeter. It blocks unauthorized, spoofed, or malicious traffic from exiting the internal network, for example, preventing data exfiltration, spoofed source IPs, or C2 communication outbound. Ingress filtering checks incoming or entering packets, anti-spoofing blocks unwanted inbound traffic, and TCP intercept is proxy intercepts and validates TCP handshakes to prevent SYN flood denial of service attacks, and rate limiting restricts traffic volume and speed to mitigate floods, not header scanning for authorization. Question number 55. Which of the following techniques is also called a one-click attack or session riding and is used by an attacker to exploit a victim's active session with a trusted site to perform malicious activities? And the options are option A, cross-site request forgery attack. Option B, cross-site script attack. Option C, session replay attack. And option D, session fixation. And the correct option is option A, cross-site request forgery attack. And the explanation is, so cross-site request forgery, also known as one-click attack or session riding, tricks a logged-in victim into unknowingly submitting a malicious request to a trusted website where they have an active authenticated session. The attacker exploits the browser's automatic inclusion of cookies, tokens to perform unauthorized actions, for example, changing password, transferring funds, without the victim's knowledge. Cross-site script attack injects malicious scripts into web pages viewed by users. Session replay attacks captures and replays legitimate session data to impersonate the user. And session fixation forces a victim to use a preset session ID controlled by the attacker. Question number 56. An attacker aims to hack an organization and gather sensitive information. In this process, they lure an employee of the organization into clicking on a fake link which appears legitimate but redirects user to the attacker's server. The attacker then forwards the request to the legitimate server on behalf of the victim. Which of the following types of attack is performed by the attacker in the above scenario? Option A, man in the middle attack. Option B, cross-site script attack. Option C, session replay attack. And option D, session hijacking using proxy servers. And the correct option is option D, session hijacking using proxy server. And the explanation is, so the correct option is actually not option D, rather option A. So option A, man in the middle, is the correct option. And the explanation is, so man in the middle attack covered in the CEH sniffing session hijacking module occurs when the attacker positions themselves between the victim and the legitimate server by luring the victim to click a fake phishing link that routes traffic through the attacker's server, for example via phishing page or malicious proxy. The attacker intercepts, reads, modifies, or steals sensitive data such as credentials and session tokens while transparently forwarding requests and responses to the real server. This matches the scenario exactly. Cross-site script attack injects malicious scripts into trusted websites viewed by users. Session replay attack captures and reuses a legitimate session token and packet to impersonate the user. And session hijacking using proxy servers involves stealing session IDs, often via man in the middle attack, but the core technique described is man in the middle interception via redirection and proxy. Question number 57. In which of the following types of hijacking can an attacker inject malicious data or commands into intercepted communication in a TCP session, even if the victim disables source routing? Option A, reset hijacking. Option B, blind hijacking. Option C, UDP hijacking. And option D, session fixation. And the correct option is option B, blind hijacking. And the explanation is, so blind hijacking covered in CEH session hijacking module occurs when the attacker cannot see the victim's traffic, for example due to being off path or on a different network segment. The attacker predicts TCP sequence numbers and injects forged packets, data and commands into the session. It works even if source routing is disabled because it relies on sequence prediction and spoofing, not source routed packets. Reset hijacking sends forged reset packets to terminate a TCP session. Disruption, not injection of data and commands. UDP hijacking targets connectionless UDP, which involves no sequence number, simple spoofing but not TCP specific. Session fixation forces victim to use attacker controlled session ID, web application attack, not TCP injection. Question number 58. Which of the following types of IDS alerts, that is intrusion detection system alerts, is an alarm raised when no actual attack is in progress? Option A, true positive. Option B, false positive. Option C, true negative. And option D, false negative. And the correct option is option B, false positive. And the explanation is, so false positive covered in CEH intrusion detection systems module occurs when an IDS raises an alarm for normal or benign activity that it mistakenly identifies as malicious, whereas no real attack is in progress, but the system generates unnecessary alerts which wastes analyst time and causes alert fatigue. True positive is clearly detects and alerts on a real attack. True negative correctly identifies normal activity and does not alert. And false negative fails to detect a real attack, which is most dangerous because attack goes unnoticed. Question number 59. Which of the following firewalls works at the session layer of the OSI model or TCP layer of TCP/IP, forwards data packet between networks without verification and blocks incoming packets from the host but allows traffic to pass through? Option A, packet filtering firewall. Option B, circuit level gateway firewall. Option C, application level firewall. And option D, application proxy. And the correct option is option B, circuit level gateway firewall. And the explanation is, so the circuit level gateway firewall covered in CEH firewall and honeypots module operates at the session layer, that is layer 5 of OSI or TCP layer of TCP/IP. It validates TCP handshakes, creates a circuit session but does not inspect packet contents, that is forwards data without deep verification. It typically allows outbound connection and blocks unsolicited incoming packets. Stateful-like behavior for established sessions, making it transparent to user while providing basic protection. Packet filtering firewall works at network layer, that is layer 3. It inspects IP TCP headers and may be stateless or stateful. Application layer firewall operates at application layer, that is layer 7. It inspects and filters content deeply. While application proxy is also a layer 7 and acts as intermediary, terminates and reinitiates connection with full content inspection. Question number 60. Which of the following is an intrusion detection system evasion technique used by attackers to encode an attack packet payload in such a manner that the destination host can decode the packet but not the IDS? Option A, evasion. Option B, session splicing. Option C, obfuscating. And option D, fragmentation. And the correct option is option C, obfuscating. And the explanation is, so obfuscating, covered in CEH sniffing and IDS evasion module, involves encoding or transforming the attack payload, for example using Unicode, hex, base 64 or custom encoding, so the target host and application can decode and process it normally, while the IDS fails to recognize the malicious pattern due to its signature or normalization limitations. This makes the attack invisible to signature-based or poorly configured anomaly-based intrusion detection system. Evasion is a general term for any technique to avoid IDS detection, not specific. Session splicing sends attack data in small out-of-order TCP segments over time to confuse reassembly by IDS, and fragmentation breaks packets into tiny IP fragments, so IDS may fail to reassemble properly while host does. Question number 61. In which of the following techniques does an attacker use a combination of upper and lowercase letters in an cross-site scripting payload to bypass the WAF, that is Web Application Firewall? Option A, using hex encoding to bypass the WAF. Option B, using ASCII values to bypass the WAF. Option C, using obfuscation to bypass the WAF. And option D, using ICMP tunneling. And the correct option is option C, using obfuscation to bypass the WAF, that is Web Application Firewall, and the explanation is so obfuscation covered in CEH web application hacking WAF bypass section involves altering the appearance of malicious payload. For example, mixing upper and lower case letters like this one and this, or random case variations to evade signature based or regex rules in web application firewalls that look for exact strings like script. The browser still intercepts it normally as valid JavaScript. Hex encoding uses this format. For example, this to encode characters. ASCII value uses character codes. For example, string from character code. And ICMP tunneling is data exfiltration via ICMP packets, not cross-site scripting or web application firewall related. Question number 62. One of the following techniques redirect all malicious network traffic to a honeypot after any intrusion attempt is detected. Attackers can identify such honeypots by examining specific TCP/IP parameters such as the round trip time (RTT), time to leave (TLL), and TCP timestamp. Which is this technique? Option A, fake AP access point. Option B, snort inline. Option C, user mode Linux UML, and option D, bait and switch. And the correct option is option D, bait and switch. And the explanation is so bait and switch covered in CEH evading IDS firewall and honeypot module redirect suspicious and malicious traffic to a honeypot once an intrusion is detected, for example via intrusion prevention system and intrusion detection system integration. Attackers detect it by analyzing TCP/IP anomalies like unusual RTT, that is extra hop delay, TTL, that is decremented differently, or TCP timestamps, inconsistent values caused by the redirection. Fake AP or rogue wireless access point for phishing and evil twin attacks. Snort inline is inline IPS mode of snort for packet modification and drop, not redirect to honeypot. And user mode Linux UML is virtual Linux kernel for isolated testing used in high interaction honeypots, not redirection. Question number 63. Which of the following web server components is located between the web client and web server to pass all the requests and is also used to prevent IP blocking and maintain anonymity? Option A, server root. Option B, web proxy. Option C, virtual document tree, and option D, virtual hosting. The correct option is option B, web proxy. And the explanation is so web proxy covered in CEH footprinting and reconnaissance web application hacking module acts as an intermediary between the client, that is browser, and the target web server. It forwards all requests and responses, hiding the client's real IP address from the target server. This prevents IP blocking, for example, rate limiting and geo blocks, and maintains anonymity during scanning, enumeration, or attacks. Server root is the base directory where web server files are stored, not an intermediary. Virtual document tree is the logical file structure for hosting multiple sites, content organization, and virtual hosting is technique to host multiple websites on a single server, IP address, name based or IP based. Question number 64. In which of the following attack types does an attacker use compromised PCs with spoofed IP addresses to intensify distributed denial of service attack on the victim's DNS server? by exploiting the DNS recursive method. Option A, DOS and DDoS attack. Option B, DNS server hijacking. Option C, DNS amplification attack. And option D, directory traversal attack. And the correct option is option C, DNS amplification attack. And the explanation is, so DNS amplification attack code in CEH DOS DDoS module is a reflection amplification DDoS technique. The attacker spoofs the victim's IP as source and sends small DNS queries, for example, any or eDNS0 request to open recursive DNS servers. These servers respond with much larger replies, amplification factor 50x plus, flooding the victim's DNS server with unsolicited traffic from many compromised reflective sources, intensifying the DDoS via spoofed IPs and recursive resolution. DDoS and DOS are general terms and are too broad, not specific to DNS amplification. DNS server hijacking redirects DNS resolution to attacker controlled server, for example, cache poisoning, not amplification. And directory traversal attack exploits file path vulnerabilities to access redirected files, which is a web application attack, not DDoS and DNS. Question number 65. In which of the following attack types does an attacker exploit vulnerabilities that evolve from the unsafe use of functions in an application in public web server to send crafted requests to internal or backend servers? Option A, SSH brute forcing. Option B, web server password cracking. Option C, server-side request forgery. And option D, web server misconfiguration. And the explanation is option C, server-side request forgery. And the explanation is, so server-side request forgery SSRF code in CEH web application hacking module exploits unsafe URL handling or request function, for example, call, file, get, content, fetch in web application. An attacker crafts malicious input URLs to trick the public-facing server into sending requests to internal and backend systems, cloud metadata services or restricted networks, allowing port scanning, data exfiltration or access to internal resources. SSH brute forcing, repeatedly guessing SSH login credential. Web server password cracking is attempting to crack admin web panel passwords. And web server misconfiguration is exploiting exposed directories, default credentials, etc., not sending crafted requests to internal servers. Question number 66. In which of the following attack types does an attacker modify the content of a web page by examining its HTML code and identifying form fields that lack valid constraints? Option A, directory traversal. Option B, buffer overflow attack. Option C, command injection attack. And option D, cross-site scripting attack. And the correct option is option D, cross-site scripting attack. And the explanation is, so cross-site scripting attack code in CEH web application hacking module involves injecting malicious scripts into web pages viewed by other users. Attackers inspect the HTML source code, locate input fields such as forms, search boxes, and comments without proper validation, sanitization, and constraint, and submit crafted payloads to modify page content, steal cookies and session, or perform action on behalf of the victims. Directory traversal exploits path traversal to access restricted files outside the web root. Buffer overflow attack overwrites memory by sending excessive data to vulnerable applications not related to HTML form fields. And command injection attack injects operating system commands into input fields that pass data to system shell. For example, this command. Question number 67. Which of the following is a technique used by an attacker to gather valuable system level data such as account details, operating system, software versions, server names, and database schema details? Option A, who is? Option B, session hijacking. Option C, web server footprinting. And option D, vulnerability scanning. And the correct option is option C, web server footprinting. And the explanation is, so web server footprinting, code in CEH footprinting and reconnaissance module, is the process of collecting detailed information about a target web server and its environment during the reconnaissance phase. Attackers use techniques like banner grabbing, HTTP header analysis, error message leakage, default page inspection, and tools, for example, Netcat, Telnet, and WhatsApp, to extract operating system and version, web server software version, for example, Apache 2.4.41, server names and host, database types, and schema hints via error pages or verbose responses, and account details from misconfigured directories or responses. This passive and active gathering helps map the attack surface. Who is provides domain registration information such as registrar, contact, and creation date, not system level details. Session hijacking is active attack to steal and take over user sessions, which is post exploitation. And vulnerability scanning identifies exploitable weaknesses after footprinting, not primarily for gathering operating system and software version/schema. Question number 68. Which of the following modules establishes a communication channel between the Metasploit framework and a victim host? Option A, exploit module. Option B, auxiliary module. Option C, payload module. And option D, NOPS module. And the correct option is option C, payload module. So in CEH module 12, hacking with Metasploit or system hacking, the payload module is responsible for delivering and establishing a communication channel, for example, Metapredator shell, reverse bind shell between the Metasploit framework and the compromised victim host after successful exploitation. It provides the post-exploitation interface for control, command execution, and file access. Exploit module targets and exploits a vulnerability to gain access and does not maintain the channel. Auxiliary module performs scanning, fuzzing, and denial of service or other support tasks and does not involve shell or channel. And NOPS module generates no operation instruction to pad payloads and help evade detection. It supports exploits and not communication. Question number 69. Which of the following web services is designed to make services more productive and uses many underlying HTTP concepts to define the services? Option A, SOAP. Option B, RESTful. Option C, XML-RPC. And option D, JSON-RPC. And the correct option is option B, RESTful. And the explanation is, so RESTful, that is representational state transfer web services, are designed for simplicity, scalability, and high productivity. They leverage core HTTP concepts and methods: get, post, put, delete, and head, etc., status codes, URIs, and stateless communication to define and interact with resources, making development faster and more efficient compared to protocol-heavy alternatives. SOAP is a heavyweight XML-based protocol with strict standards, envelopes, and WS extensions, which is more complex and less productive. XML-RPC is older XML-based remote procedure call or HTTP and is limited to procedure calls, not resource-oriented. And JSON-RPC is lightweight RPC or HTTP/JSON. It is procedure oriented, not fully utilizing HTTP methods and verbs like REST. Question number 70. In which of the following web application threads does an attacker manipulate the variables that reference files with // sequences and its variations? Option A, unvalidated redirects and forwards. Option B, hidden fields manipulation attack. Option C, directory traversal attack. And option D, cookie session poisoning. And the correct option is option C, directory traversal attack. And the explanation is, so directory traversal attack, also called path traversal, exploits insufficient input validation in file path parameters. An attacker appends sequences such as // and this sequence or other encoded variations to navigate outside the intended directory and access restricted files. For example, the file /etc/password config files source code on the server. Other option, unvalidated redirects and forwards, manipulates redirect URLs to send users to malicious sites. Hidden field manipulation attack alters values in hidden HTML form fields to change prices, roles, etc. And cookie session poisoning modifies cookie session data to hijack sessions or escalate privileges. Question number 71. Which of the following is a process that can be used to convert object data into a linear format for transportation to a different system or different network? Option A, deserialization. Option B, serialization. Option C, insecure deserialization. And option D, directory traversal. And the correct option is option B, serialization. And the explanation is, so serialization is the process of converting complex objects, for example, in-memory data structures, classes, and arrays, into a linear byte stream or string format, for example, JSON, XML, and binary, so they can be transmitted over a network, saved to disk, or sent to another system. This is a standard and safe mechanism in many programming languages and web services. Deserialization is the reverse process, converting the linear format back into an object, and can be dangerous if untrusted data is processed. Insecure deserialization is a vulnerability where attackers exploit unsafe deserialization to execute malicious code or manipulate application logic. And directory traversal is a file path attack using // sequences to access restricted files unrelated to data conversion. Question number 72. Which of the following attacks runs malicious code inside a browser and causes an infection that persists even after closing or browsing away from the malicious web page that spread the infection? Option A, clickjacking attack. Option B, DNS rebinding attack. Option C, marionette attack. And option D, XML poisoning. And the correct option is option C, marionette attack. And the explanation is, so marionette attack, code in CEH emerging threat / browser based malware section, executes malicious JavaScript in victim's browser that turns the browser into a botnet node using service workers, IndexedDB, or Cache API. The infection persists even after closing the tab browser because it registers a service worker that survives page reloads and browser restarts, allowing continued command and control communication and malicious actions without revisiting the web page. Clickjacking attack tricks user into clicking hidden elements, UI redressing, no persistent code execution. DNS rebinding attack bypasses same origin policy by changing DNS resolution to attacker controlled IP. It affects network access, not persistent browser infection. And XML poisoning injects malicious XML data to disrupt parsing or exploit XML processors. For example, XXE not browser persistent. Question number 73. In which of the following attacks does an attacker obtain the user session ID and then reuse it to gain unauthorized access to a target user account? Option A, session token prediction. Option B, session token tampering. Option C, session hijacking. And option D, session replay. And the correct option is option C, session hijacking. And the explanation is, so session hijacking covered in CEH session hijacking module occurs when an attacker steals or obtains a valid session ID such as cookie, token or URL parameter from a legitimate user and reuses it to impersonate that user, that is gaining unauthorized access to the active session and performing actions on the victim. For example, accessing account, changing settings. Common methods include sniffing, cross-site scripting, man-in-the-middle attack, or malware. Session token prediction guesses future session IDs based on patterns, for example, sequential or weak randomness, without stealing an existing one. Session token tampering modifies or alters the session token's content, for example, changing user role in unsigned JWT to escalate privileges. And session replay captures and replays a legitimate request-response pair, often with fixed non-timestamp issues, not reusing the session ID itself for ongoing access. Question number 74. In which of the following security risks does an API accidentally expose internal variable or objects because of improper binding and filtering based on a whitelist, allowing attackers with unauthorized access to modify object properties? Option A, broken object level authorization. Option B, mass assignment. Option C, improper assets management. And option D, injection. And the correct option is option B, mass assignment. And the explanation is, so mass assignment covered in OWASP API Security Top 10 API 2 2023, broken object property level authorization and mass assignment occurs when an API automatically binds client submitted data, for example, JSON payload, to object properties without proper whitelisting or filtering. This exposes internal and sensitive fields, for example, is admin role, user ID, allowing attackers to add or modify unauthorized properties in the request, for example, is admin true, and gain elevated privileges or access restricted data. Broken object level authorization fails to check if user can access or modify a specific object, for example, wrong user ID in URL, not about automatic binding of extra fields. Improper assets management is poor inventory versioning of APIs, which leads to exposed deprecated endpoints. And injection is injecting malicious code, that is SQL command, etc., into inputs not related to object property binding. Question number 75. Which of the following encoding schemes represents any binary data using only printable ASCII characters and is used for encoding email attachments for safe transmission or SMTP, that is Simple Mail Transfer Protocol? Option A, URL encoding. Option B, Unicode encoding. Option C, base 64 encoding. And option D, hex encoding. And the correct option is Option C, base 64 encoding, and the explanation is, so base 64 encoding converts binary data such as images, executables and PDF into a set of 64 printable ASCII characters. This ensures safe transmission over text-based protocol like SMTP that is used for email, which may corrupt or misinterpret raw binary data. It is the standard method used in MIME for encoding email attachments. URL encoding encodes special characters for safe use in URLs, not for binary attachment. Unicode encoding represents text characters in various formats such as UTF-8, UTF-16, not for arbitrary binary data, and hex encoding converts binary to hexadecimal strings and which is readable but doubles the size and not SMTP safe by default. Question number 76. Which of the following attacks is performed by asking the appropriate question to an application database with multiple valid statements evaluated as true or false being supplied in affected parameters in the HTTP request? Option A, heavy query. Option B, error-based SQL injection. Option C, no error message returned. And option D, Boolean exploitation. And the correct option is option D, Boolean exploitation. And the explanation is, so this is Boolean based blind SQL injection, also called Boolean exploitation in CEH and similar exams. The attacker supplies multiple true-false SQL conditions in an HTTP parameter and observes differences in application response. For example, page content changes, element appear, disappear, to infer data bit by bit exactly as described, asking the appropriate questions, multiple valid statements evaluated as true or false. Why the other options are wrong? Option A, heavy query is not a SQL injection technique. Option B, error-based SQL injection relies on visible database error messages leaking info. And option C, no error message returned is too general, describes any blind SQL injection, not the specific true-false question method. Question number 77. Which of the following is an evasion technique that involves replacing characters with their ASCII codes in hexadecimal form and prefixing each code point with the %sign? Option A, URL encoding. Option B, sophisticated matches. Option C, null byte. And option D, case variation. And the correct option is option A, URL encoding. And the explanation is, so URL encoding, also called person encoding, is an evasion technique where characters are replaced with their ASCII hexadecimal values prefixed by a %sign. For example, space by %20 and so on. So these ASCII characters are replaced by a hexadecimal value and prefixed by this %sign. So attackers use this in SQL injection, cross-site scripting or other payloads to bypass weak filters, web application firewalls that look for literal dangerous characters but fail to decode the % encoded version before checking. Why other options are wrong? So option B, sophisticated matches, not a standard evasion technique name. Option C, null byte involves injecting null byte to truncate strings, file names, for example, in file inclusion or path traversal. And option D, case variation, is changing letter case, for example, select instead of select to bypass case sensitive filters. Question number 78. Which of the following protocols uses advanced encryption standard and the counter mode cipher block chaining message authentication code protocol, that is CCMP, for wireless data encryption? Option A, web, that is wired equivalent privacy. option B WPA3, option C WPA2, and option D WPA. And the correct option is option C WPA2, and the explanation is so WPA2 Wi-Fi protected access to based on IEEE 802.11i mandates the use of AES, that is Advanced Encryption Standard, with CCMP, that is Counter Mode Cipher Blockchaining Message Authentication Code Protocol, for wireless data encryption and integrity protection. It replaces the weaker TKIP which was used in WPA and is the protocol most classically associated with AES CCMP. So why the other options are wrong? Option A, web uses RC4 stream cipher which is very weak and does not use AES or CCMP. WPA3 uses AES but primarily with GCMP, which is Gallios counter mode in many implementations. CCMP-128 or AES-128 is allowed as minimum in personal port but not the defining protocol. WPA3 focuses on stronger modern modes like GCM. WPA uses TKIP or C4 based for encryption, not AES-CCMP. TKIP was a temporary upgrade over web. Question number 79. Which of the following is a mode of operation that includes EAP, EAP or radius for centralized client authentication using multiple authentication methods such as token cards, Kerberos, and certificates? Option A, WPA3 personal, option B, WPA2 personal, option C, WPA3 enterprise, and option D, WPA2 enterprise. And the correct option is option C, WPA3 enterprise, and the explanation is so WPA3 enterprise and WPA2 enterprise before it uses 802.1x authentication framework with EAP, that is extensible authentication protocol methods transported over radius to a central authentication server. Enterprise modes are designed for business corporate environments requiring centralized user device authentication, unlike personal modes which uses pre-shared key PSK. So why the other options are wrong? So WPA3 personal uses SAE, that is simultaneous authentication equals with a pre-shared passcode, no EAP or radius or centralized authentication. WPA2 personal uses PSK, pre-shared key only, no centralized authentication server or EAP methods, and WPA2 enterprise also uses EAP and radius with the same authentication methods, but the question asks for a mode that includes them. So WPA3 enterprise is the modern standard one listed and still fully supports all those EAP methods. Question number 80. In which of the following attacks does an attacker install a fake communication tower between two authentic endpoints with the intention of misleading a user and interrupting the data transmission between the user and a real tower to hijack an active session? Option A, rogue access point attack. Option B, key reinstallation attack. Option C, war driving, and option D, alter attack. And the correct option is, so the correct option is option D, alter attack. And the explanation is, so the alter attack to 2018 research on LTE vulnerabilities involved an attacker setting up a fake malicious LTE base station, E node B or cell tower that acts as a man in the middle relay. The attacker pretends to be a legitimate tower to the victim's device while also impersonating the victim to the real network. This intercepts and manipulates traffic, for example, via DNS spoofing by altering unintegrity protected packets, misleading the user, interrupting normal transmission, and allowing session hijacking or redirection to malicious sites. So why the other options are wrong? Option A, rogue AP attacks involves a fake Wi-Fi access point, not a cellular tower to intercept wireless LAN traffic. Option B, key reinstallation attack is crack which exploits WPA2 handshake to reinstall keys and decrypt Wi-Fi traffic, no fake tower involved. And option C, war drive is passive scanning, driving to detect and make Wi-Fi networks, no interception or hijacking. Question number 81. Which of the following attacks does not directly recover a web key and requires at least one data packet from a target AP for initiation? Option A, MAC spoofing attack. Option B, evil twin attack. Option C, fragmentation attack. And option D, de-authentication attack. And the correct option is option C, fragmentation attack. And the explanation is, so the fragmentation attack via airplay-nd-fragment does not directly recover the web key. Instead, it recovers up to 1500 bytes of PRGA, that is pseudo random number generation algorithm key stream, by exploiting web fragmentation reassembly flaws. It requires at least one data packet captured from the target AP to initiate, uses a small part of its keying material to craft and inject fragmented packets, hoping the AP echoes them back for more keystream. The PRGA can then help forget inject packets, for example with packet forge-ng, but key cracking comes from other collected traffic. So why the other options are wrong? MAC spoofing attack spoofs a client's MAC address to assuage inject and can enable attacks but does not require a specific data packet from AP for injection and is not primarily about key recovery. Option B, evil twin attack sets up a rogue fake access point to trick clients into connecting. No direct web key recovery, aims at credential theft or man-in-the-middle attack. No need for target AP data packet. And option D, de-authentication attack floods de-authentication frames to disconnect clients. Denial of service forces re-authentication reassociation to generate more traffic for key recovery tools but does not require capturing a data packet from AP to start. Works on management frames. Question number 82. Which of the following Bluetooth attacks is similar to the ICMP ping of death attack, where the attacker sends an oversized ping packet to a victim's device to cause a buffer overflow? Option A, blue snarfing. Option B, blue sniff. Option C, blue jacking. And option D, blue smacking. And the correct option is option D, blue smacking. And the explanation is, so blue smacking is a Bluetooth denial of service attack similar to the classic ICMP ping of death or ping flood with oversized packets. The attacker sends oversized or malformed L2 cap logic link control and adaptation protocol ping packets via Bluetooth's LMP or L2 cap echo request to the victim's device. These oversized packets exceed the device's buffer size, triggering a buffer overflow, crash, freeze, or reboot of the Bluetooth stack firmware. So why the other options are wrong? Option A, blue snarfing is unauthorized extraction of data, contacts, calendar, files from a vulnerable device via OBEX, no oversized packets or DOS. Option B, blue sniff is passive scanning sniffing tool to discover Bluetooth devices and their MAC addresses, reconnaissance only. And option C, blue jacking is sending unsolicited messages, for example, vCard, business card, spam to nearby devices, annoying but not destructive or buffer overflow based. Question number 83. Which of the following techniques involve sending unsolicited messages over Bluetooth to Bluetooth enabled devices such as mobile phones and laptops? Option A, blue jacking. Option B, blue smacking. Option C, blue bugging. And option D, blue printing. And the correct option is option A, blue jacking. And the explanation is, so blue jacking is a Bluetooth based technique where an attacker sends unsolicited messages, typically vCard and business card spam or short text notes over Bluetooth to nearby Bluetooth enabled devices like mobile phones, laptops or PDAs. It exploits the object exchange protocol to push harmless but annoying messages without pairing or gaining control. The goal is usually mischief, pranking or advertising, not data theft or device compromise. Why the other options are wrong? So blue smacking is DOS attack sending oversized L2 cap ping packets to crash or freeze the Bluetooth stack, similar to ping of death. Blue bugging exploits vulnerabilities to gain unauthorized full access and control over a device, for example making calls, reading messages or installing software. And blueprinting is reconnaissance technique to gather information about Bluetooth devices, manufacturer, model, firmware version and feature. Fingerprinting. Question number 84. In which of the following attacks does an attacker dump memory by rebooting a victim's device with a malicious operating system and then extract sensitive data from the dumped memory? Option A, iOS jailbreaking. Option B, OS data caching. Option C, carrier loaded software. And option D, user initiated code. And the correct option is option B, OS data caching. And the explanation is, so OS data caching refers to the attack where sensitive data, for example encryption keys, credentials, remains cached in RAM OS memory. An attacker with physical access reboots the victim's device into a malicious OS, for example from USB or through CD, and performs a memory dump of the residual RAM contents and extracts the sensitive data from that dump. This aligns exactly with the described technique, a variant or naming for aspects of cold boot reset attacks in some training materials. So why the other options are wrong? Option A, iOS jailbreaking is bypassing iOS restrictions to gain root access and install unauthorized application. No reboot with malicious OS or memory dumping for extraction. Option C, carrier loaded software is pre-installed bloatware or carrier maps on mobile devices unrelated to memory dumping via reboot. And option D, user initiated code is generic term for code run by the user, for example scripts, no relation to malicious OS reboot and memory extraction. Question number 85. In one of the following jailbreaking techniques, a user turns their device off and back on, following which the device starts up completely and the kernel is patched without the help of a computer. Which is this jailbreaking technique? Option A, semi-tethered jailbreaking. Option B, tethered jailbreaking. Option C, semi-untethered jailbreaking. And option D, untethered jailbreaking. And the correct option is untethered jailbreaking. And the explanation is, so untethered jailbreaking is a technique where after the initial jailbreak, the user can turn the device off and back on, that is reboot, and the device starts up completely with the kernel patched automatically. No computer or on-device app is needed to reapply the jailbreak. The jailbreak persists through reboots because the exploit patch is applied during the boot process itself. Why the other options are wrong? Option A, semi-tethered jailbreaking device boots normally after reboot, no brick, but the jailbreak patch kernel tweaks is disabled until reapplied via a computer. Tethered jailbreaking is where device requires a computer every reboot to boot at all, or it gets stuck or bricked, kernel not patched without help. And semi-untethered jailbreaking device boots normally but jailbreak disabled after reboot, reapplied via on-device app, no computer needed but still manual step. Question number 86. John, an employee of an organization, always connects to the corporate network using his own mobile device. Which of the following best practices prevent BYOD, that is, bring your own device risk, when John connects to the corporate network? And the options are: option A, improperly disposing of a device; option B, not reporting a lost or stolen device; option C, providing support for many different devices; and option D, separating personal and private data. And the correct option is option D, separating the personal and private data. And the explanation is: so separated personal and corporate or private data on a BYOD device via containerization, mobile device management profiles or work profiles is a key best practice. It isolates corporate data, prevents leakage, and enables secure remote wipe of work data only, and reduces compliance risk when connecting to the corporate network. So why the other options are wrong? Option A, improperly disposing of a device increases risk, that is data exposure. Proper wiping or disposal is the correct practice. Option B, not reporting a lost or stolen device. It worsens risk. Delayed response, immediate reporting is required. And option C, providing support for many different devices raises complexity and security gaps. Limiting and standardizing devices is better. Question number 87. In one of the following Internet of Things attacks, attackers intercept legitimate messages from a valid communication and continuously send the intercepted message to the target device to perform a denial of service attack or crash the target device. Which is this Internet of Things attack? Option A, replay attack; option B, exploit kits; option C, network pivoting; and option D, bluebone attack. And the correct option is option A, replay attack. And the explanation is: so in a replay attack on Internet of Things devices, attackers intercept or capture legitimate messages from valid communication, then continuously replay and send the intercepted messages to the target device. This floods the device, consumes resources, for example bandwidth, processing power, performs a denial of service, or crashes it due to repeated processing of the same command/packet. So why the other options are wrong? Option B, exploit kits are automated tools, packages that scan for and exploit software vulnerabilities to deliver malware, not about intercepting and replaying messages for denial of service. Option C, network pivoting is a technique where attackers use a compromised system to access and attack other systems in a network unrelated to message interception and replay. And option D, bluebone attack is specific Bluetooth vulnerability that exploit allowing remote code execution or takeover without pairing and user interaction, not focused on replaying intercepted messages for DOS. Question number 88. Which of the following RFC rack or RF crack commands is used by an attacker to perform an incremental scan on a target Internet of Things device while launching a rolling code attack? And so these are the options. Option A, Python rfcrack.py-b-v; Option B, Python rfcrack.py-j-f. Option C, Python rfcrack-py and these parameters, and option D, Python rfcrack.py-I. And the correct option is option A, Python rfcrack.py-b-v and 5000000. And the explanation is, so in rfcrack, a sub-gigahertz SDR attack tool used in CEH for IoT radio frequency hacking, the -b flag enables brute force incremental mode scanning, incrementing values, and -v sets the value increment step or starting point for rolling code attacks. This command performs an incremental scan stepping through code values on a target Internet of Things device while attempting a rolling code attack by trying sequential and incremental codes to bypass the rolling mechanism. So why the other options are wrong? Option B, -J is typically for jamming and -F sets frequency, which is used for interference, not incremental scanning or rolling code. Option C, the -R is for receive capture mode and -M sets modulation, for example 2FSK, and -F sets frequency for capturing signals, not incremental and rolling attacks. And option D, Python rfcrack.py-I. -I is often for interactive mode or inspection and does not specifically perform incremental scanning for rolling codes. Question number 89. Which of the following components of an Internet of Things framework must incorporate strong encryption techniques for secure communications between endpoints and the authentication mechanism for the edge components? And the options are option A, gateway, option B, cloud platform, option C, mobile, and option D, edge. And the correct option is option A, gateway. And the explanation is, so in an Internet of Things framework CEH module 18, the gateway must use strong encryption, for example TLS, for secure communication between endpoints and handle authentication for edge components/devices. It acts as the secure bridge, enforcing policies and protecting data flow. So why the other options are wrong? Option B, cloud platform, which handles data storage analytics, not primarily responsible for edge authentication or endpoint communication bridging. Option C, mobile, which is user interface application, not core for edge Internet of Things encryption and authentication. And option D, edge devices perform local processing but rely on gateways for strong encryption and centralized authentication. Question number 90. Through which of the following SCADA vulnerabilities does an attacker exploit code security issues that include out-of-band read-write vulnerabilities and heap and stack-based buffer overflow? Option A, credential management, option B, code injection, option C, lack of authorization, and option D, memory corruption. And the correct option is option D, memory corruption. And the explanation is, so in SCADA, industrial control system CEH modules on OT, operational technology, SCADA hacking, memory corruption vulnerability arise from code security flaws like out of bounds and read-write, heap-based buffer overflows, and stack-based buffer overflows. Attackers exploit these to overwrite memory, cause crashes, which is denial of service, leak data, or achieve arbitrary code execution, remote control of industrial devices and PLCs. So why the other options are wrong? Option A, credential management involves weak passwords, storage or reuse unrelated to memory and buffer issues. Option B, code injection exploits input to run attacker code, for example, SQL script injection, not specific to out of bounds or buffer overflow. And option C, lack of authorization allows unauthorized access action and does not involve exploiting memory read write or overflow flaws. Question number 91. Which of the following cloud services provides data processing services such as Internet of Things services for connected devices, mobile and web applications, and batch and stream processing? Option A, function as a service. Option B, container as a service. Option C, security as a service. And option D, identity as a service. And the correct option is option A, function as a service. And the explanation is, so in CEH module 19, cloud computing, function as a service, also called serverless computing, provides data processing services for event-driven workloads. It supports Internet of Things services for connected devices, for example, processing sensor data triggers, mobile and web applications, backend functions and APIs, and batch and stream processing, short-lived function for data pipeline streams without managing servers. So why other are wrong? So container as a service manages container orchestration, for example, Kubernetes focuses on deployment and scaling, not broad data processing and Internet of Things. Security as a service delivers cloud-based security tools, for example, firewalls, antivirus, and is unrelated to data processing. And identity as a service provides identity management authentication, for example, SSO, no data processing features. Question number 92. Which of the following cloud deployment model is also known as the internal or corporate cloud and is a cloud infrastructure operated by a single organization and implemented within a corporate firewall? Option A, community cloud. Option B, multi-cloud. Option C, private cloud. And option D, public cloud. And the correct option is option C, private cloud. So a private cloud, also known as internal or corporate cloud, is a cloud infrastructure operated solely by and for a single organization. It is implemented within the organization on corporate firewall or on-premises data center, providing dedicated resources, greater control, security, and customization compared to shared model. This aligns with CEH module 19 on cloud computing definitions. So why the other options are wrong? Option A, community cloud is shared infrastructure for multiple organizations with similar requirements. For example, regulatory compliance not limited to a single organization. Option B, multi-cloud is a strategy using services from multiple public cloud providers simultaneously, not a single dedicated deployment model. And option D, public cloud is shared infrastructure operated by a third-party provider, for example, AWS or Azure, and accessible over the internet to multiple customers, not internal or behind a corporate firewall. Question number 93. Which of the following is the component in the Docker architecture where images are stored and pulled and can be either private or public? Option A, Docker daemon. Option B, Docker client. Option C, Docker registries. And option D, Docker objects. And the correct option is option C, Docker registries. And the explanation is, so in Docker architecture relevant to CEH cloud container security modules, Docker registries are the components where Docker images are stored, distributed, and pulled from. They can be public, for example, Docker Hub open to anyone, or private, for example, self-hosted AWS ECR or enterprise registries, allowing secure sharing and access control for images via Docker pull and Docker push. So why the other options are wrong? Option A, Docker daemon is the background service, Docker D, that manages containers, images, networks on the host. It pulls and pushes to registries but does not store them. Option B, Docker client is the CLI Docker command users interact with to issue commands. It communicates with the daemon, not a strong storage component. And option D, Docker objects are general term for runtime entities like images, containers, networks, volume, not the storage pool location registries hold the images. Question number 94. Which of the following is a serverless security risk due to the poor design of identity and access controls, paving the way for attackers to identify missing resources such as open APIs and public cloud storage and leading to system business logic breakage and execution flow disruption? Option A, injection. Option B, broken authentication. Option C, sensitive data exposure. And option D, XML external entities or XXE. And the correct option is option B, broken authentication. And the explanation is, so in serverless environment, CEH cloud security module, broken authentication arises from poor design of identity and access control. For example, weak identity and access management roles, misconfigured authentication mechanism, or insufficient token validation. This allows attackers to exploit flaws, enumerate, discover missing or unprotected resources like open APIs, public S3 buckets storage, bypass intended restriction, cause business logic breakage, for example, unauthorized action, and disrupt execution flow, for example, privilege escalation or function abuse. So why the other options are wrong? Option A, injection involves injecting malicious code and data, for example, SQL injection, NoSQL, and OS commands via inputs not tied to identity and access design flaws or resource discovery. Option C, sensitive data exposure occurs when data, for example, credentials, is improperly protected and transmitted unrelated to poor authentication controls, enabling resource identification and logic disruption. And option D, XML external entities, XSE, or specific XML parser vulnerability allowing external entity attacks, for example, file disclosure, not about identity and access or serverless authentication misconfiguration. Question number 95. In which of the following attacks does an attacker exploit the vulnerability residing in a bare metal cloud server and use it to implant a malicious backdoor in its firmware? And the options are option A, wrapping attack, option B, cloud-borne attack, option C, cryptanalysis attack, and option D, cross-site scripting attack. And the explanation is option B, cloud-borne attack, and the explanation is, so the cloud-borne attack exploits vulnerabilities in bare metal cloud server, for example, in BMC firmware like Supermicro hardware. An attacker gains access, overrides the firmware, and implants a persistent malicious backdoor. This backdoor survives server reclamation, reprovisioning, allowing attacks on future customers. For example, data theft, ransomware, or disruption even after reassignment. So why the other options are wrong? Option A, wrapping attack involves manipulating XML and SOAP messages in web services, for example, altering parameters unrelated to firmware or bare metal servers. Option C, cryptanalysis attack is breaking cryptographic algorithmic keys through analysis, not about exploiting hardware and firmware for backdoors. And option D, cross-site scripting attack is injecting malicious scripts into web pages for client-side execution, web application based, not firmware level in cloud hardware. Question number 96. Which of the following information does an attacker enumerate by analyzing the AWS error messages that reveal information regarding the existence of a user? Option A, enumerating AWS account IDs. Option B, enumerating S3 buckets. Option C, enumerating identity and access management roles, and option D, enumerating bucket permissions. And the correct option is option A, enumerating AWS account IDs. So in AWS Cloud Enumeration CEH Module 19 Cloud Computing Attacks, attackers analyze certain error messages, for example, from STS assume role API calls or cross-account policy updates that reveal whether a principal often tied to an account ID exists. For example, attempting to assume a role or update a trust policy with a guest ARN including an account ID returns distinct error, access denied indicating the account user role exists versus invalid principal or similar non-existent. This allows enumeration of valid AWS account IDs which are foundational for further attacks like cross-account reconnaissance. So why the other options are wrong? Option B, enumerating S3 buckets is done via bucket name guessing. 403/404 differences are tools like S3 scanner, not via user related error messages. Option C, enumerating IAM roles is possible via similar principal enumeration techniques, but the question specifies existence of a user pointing to account IDs or users, not roles primarily. And option D, enumerating bucket permissions involves listing policies or testing access, for example, via public buckets unrelated to user existence errors. Question number 97. Which of the following encryption algorithms is a large tweakable symmetric key block cipher with equal block and key sizes of 256, 512 or 1024 and involves only three operations, that is addition, rotation, XOR? Option A RC4, option B 2 fish, option C RC5 and option D 3 fish. And the correct option is option D 3 fish, and the explanation is, so 3 fish is a large tweakable symmetric key block cipher with equal block and key sizes of 256, 512 or 102 bits. It uses only three simple operations on 64-bit words: modular addition, rotation by fixed amounts, and XOR, that is ARX structure, making it efficient and easy to implement securely. It was designed as part of the skein hash function, SHA-3 finalist, and features 72 rounds for 256 512 bit version and 80 for 1024 bit. So why the other options are wrong? Option A RC4 is a stream cipher, not block, and it uses variable key sizes 40 to 2048 bits, no fixed block key quality or ARX ops. Option B 2 fish is a block cipher, 1 to 8 bit block up to 256 bit key. It uses complex operations, S boxes, MDS, etc., not tweakable in the way or ARX only. And option C RC5 is block cipher using addition, rotation, XOR, but variable block key sizes 32, 64 and 1 to 8 bit blocks, not large and fixed at 256, 512 and 1024 are tweakable as described. Question 98. Which of the following symmetric key block ciphers has either 18 rounds for 1 to 8 bit keys or 24 rounds for 256 bit keys and uses 4 8 into 8 bit S boxes that perform a fine transformation and logical operations? Option A RSA, option B Diffie-Hellman, option C Camellia, and option D YAK. And the correct option is option C Camellia. And the explanation is, so Camellia is a symmetric key block cipher, 1 to 8 bit block size with key sizes of 1 to 8, 198 or 256 bits. It uses a fiscal structure with 18 rounds for 1 to 8 bit keys and 24 rounds for 192 or 256 bit keys. It employs 4 8 into 8 bit S boxes that perform a fine transformation over GF2 key, 2 raised to the power 8 combined with logical operations for non-linearity and diffusion. So why the other options are wrong? Option A, RSA, asymmetric public key algorithm based on integer factorization, not symmetric block cipher, no rounds and S boxes. Option B, Diffie-Hellman is key exchange protocol, asymmetric, not a block cipher, no encryption rounds or S boxes. And option D, YAK is authenticated key agreement protocol, public key, not a symmetric block cipher. Question number 99. Which of the following components of public key infrastructure acts as a verifier for the certificate authority? Option A, authentication authority. Option B, registration authority. Option C, certificate management system. And option D, validation authority. And the correct option is option B, registration authority. And the explanation is, so in public key infrastructure PKI, the registration authority acts as the verifier for the certificate authority CA. The RA is responsible for verifying the identity of the certificate requester, for example, checking documents, validating ownership of domain and email, approving the request, and forwarding it to the CA for signing. This separation ensures the CA issues certificates only after proper vetting. So why the other options are wrong? Authentication authority is not a standard PKI component. Authentication is part of the registration authority functions or other systems. Certificate management system, a software tool for issuing, renewing, and revoking certificates, not the verifier role. And validation authority checks certificate validity status, for example, via OCSP CRL for relying parties, and does not verify requester identity for the CA. Question number 100. Which of the following protocols is often used for data compression, digital signing, encryption and decryption of messages, emails, files and directories, as well as to enhance the privacy of email communication? Option A, EAP. Option B, PGP, pretty good privacy. Option C, CHAP. And option D, HMAC. And the correct option is option B, PGP, pretty good privacy. And the explanation is, so PGP, pretty good privacy, is a protocol and program that combines data compression, digital signing using hashing and private keys, encryption, decryption, hybrid, symmetric, asymmetric for securing messages, emails, files and directories. It enhances email privacy by providing end-to-end confidentiality, authentication, and integrity as code in CEH cryptography modules. So why the other options are wrong? Option A, EAP, extensible authentication protocol, is used for network authentication, for example, Wi-Fi and 802.1x, not for email and file encryption or signing. Option C, CHAP, is Challenge Handshake Authentication Protocol, which provides password-based authentication over PPP, point-to-point protocol, and has no encryption, signing, or compression features. And HMAC is hash-based message authentication code used for integrity and authenticity via keyed hashing, not full encryption, decryption, or email privacy. So that's all for this video. I hope this video has been informative. So this was the part 2 covering 50 questions of our CEH series. I will soon upload the part 3. We will again which will again contain another 50 practice questions. So please like, subscribe and share the video, and see you soon in the part 3.